when Harvard astronomer Avi Loeb looked at the data from interstellar object 3I Atlas. He quoted Sherlock Holmes, "There is nothing more deceptive than an obvious fact." NASA disagrees strongly, and this clash between one of the world's most controversial scientists and America's space agency reveals something profound about how we search for truth in the cosmos. What you're about to hear will make you question everything you thought you knew about scientific consensus. This isn't science fiction. This is happening right now, about 170 million miles from Earth. And the debate about what we're seeing reveals something fascinating about how science really works when faced with the extraordinary. Let me take you through both arguments piece by piece, because this isn't about who's right or wrong. It's about how we think about evidence, probability, and the possibility that we might not be alone. On July 1, 2025, the Atlas telescope system in Chile detected something unusual fast-moving, coming from outside our solar system. They named it 3I Atlas, the third confirmed interstellar object we've ever seen. You might remember the first one, Oumuamua, back in 2017, that cigar-shaped object that tumbled through our neighborhood and disappeared before we could get a good look. The second was Borisov in 2019, a comet that behaved exactly as expected. But 3I Atlas, it's different. It's somewhere between 1,400 feet and 3.5 miles across. We're not entirely sure. It's traveling at 153,000 miles per hour. And here's the key detail. It's on what astronomers call a hyperbolic trajectory. That means it's moving too fast to be captured by the sun's gravity. It came from somewhere else, it's passing through, and it's never coming back. The question is, what exactly is it? Avi Loeb isn't some fringe theorist. He's a Harvard professor, former chair of their astronomy department and director of the Institute for Theory and Computation. His credentials are impeccable. Well, that's become complicated, because Loeb has identified what he calls 9 significant anomalies about 3I Atlas. And he's published a paper asking a question that makes most scientists uncomfortable. Is the interstellar object 3I Atlas alien technology? Let's walk through his main arguments, because whether you agree with him or not, they're worth understanding. First, the trajectory. 3I Atlas approached our solar system on a path nearly aligned with the ecliptic plane, Earth's orbit. It passed within 18 million miles of Mars, then it swung inside Earth's orbit, coming within about 130 million miles of the Sun. After that, it's headed toward Jupiter. Loeb's team calculated the odds of an interstellar object randomly passing this close to 3 major planets. The probability, less than 0.005%. To put that in perspective, that's like randomly throwing a stone into the ocean and hitting a specific boat. Not just any boat. 3 specific boats in sequence. Second, timing. The timing. When 3I Atlas reached its closest point to the Sun on October 29th, something interesting happened. From Earth's perspective, it was hidden directly behind the Sun. We couldn't see it. Loeb points out that if you were an advanced civilization sending a spacecraft, this would be the perfect moment to perform what is called a reverse Oberth maneuver. That's a technique where you fire engines at the point of maximum speed to slow down most efficiently. If 3I Atlas wanted to stay in our solar system instead of flying through, this is exactly when and where it would make that burn. And we couldn't watch it happen. Third, the physical anomalies. Hubble photographed 3I Atlas in August and noticed something odd. The dust trail wasn't behind the object as you'd expect from a comet. It was in front of it. Then, as it approached the sun, 3I Atlas brightened rapidly, much faster than typical comets, and strangest of all, it turned blue, bluer than the sun itself. That shouldn't happen. Dust and cold surfaces should make it appear red. I don't know. Redder, not bluer. When pressed, Loeb admits that 3I Atlas is most likely a comet, but he argues that the probability isn't 100%. Maybe it's 60-40. Maybe 70-30. His point is this: when something has this many statistical improbabilities stacked together, scientific integrity demands we at least consider the alternative explanation. He quotes Arthur Conan Doyle. There is nothing more deceptive than an obvious fact. NASA's position is clear and unambiguous. Meet Kshatriya, NASA's associate administrator, stated it directly. This object is a comet. It looks and behaves like a comet, and all evidence points towards it being a comet. And they have compelling evidence. The comet. As 3I Atlas approached the sun, it developed exactly what you'd expect from a comet, a fuzzy cloud of gas and dust called a coma, extending thousands of kilometers from its nucleus. The Hubble Space Telescope captured this clearly. That's ice sublimating, turning directly from solid to gas. Because of solar heating, precisely what comets do. The tail. Multiple spacecraft, including Mars Express, ExoMars Trace Gas Orbiter, and NASA's own fleet observed 3I Atlas developing a tail. Not just any tail, a blue ion tail pushed by solar wind, and a dust tail, and even what's called an anti-tail. These are textbook cometary features. The composition spectroscopic analysis shows 3I Atlas is primarily carbon dioxide ice. But it's not just carbon dioxide ice. There are other types of ice as well. For example, if you look at the surface of a comet, you can see that it is made up of two different types of ice. One type of ice is known to be carbon dioxide, and another type of ice is known to be carbon dioxide. But what does this mean? Well, first things first. Nothing unusual. Nothing artificial. It's consistent with what we see in comets from our own Oort cloud. The behavior. As for those anomalies Loeb identified, NASA and other mainstream astronomers have natural explanations for each one. The unusual brightness and color changes. That happens when different types of ice sublimate at different rates. The jets and cryovolcanism recently observed. Many comets show these features when pockets of volatile material suddenly break through to the surface. The trajectory passed multiple planets. Astronomer Jason Wright from Penn State did the math. Yes, the odds are low for any single random interstellar object, but we've now seen 3 of them. With better detection systems, we'll see more. Some will have unusual paths. That's just statistics playing out. Wright and others have systematically addressed each of Loeb's claims, showing they're within the expected range for an active comet from another star system. The blue color, probably emission from excited gas molecules that reflected sunlight. The dust trail orientation, likely an optical effect from how we're viewing the outgassing. As for the hidden maneuver behind the sun, we have observations from multiple spacecraft. Before and after, its velocity changed exactly as predicted by gravity alone. No unexplained acceleration. No burn. So who's right? Here's where this gets interesting, and why I wanted to share this with you. This debate isn't really about 3I Atlas. It's something more fundamental. How do we evaluate extraordinary claims? NASA's approach is conservative. And for good reason. Their job is to base conclusions on the most likely explanations, supported by data. In their view, if something looks like a comet, acts like a comet, and has the chemical composition of a comet, calling it a comet isn't being closed-minded, it's being scientific. But Loeb asks a question that resonates with many of us who lived through the Apollo era. And remember when we thought anything was possible? What if our standards of proof are keeping us from seeing something real? He argues that the scientific establishment has a blind spot when it comes to extraterrestrial technology, that astronomers are so conditioned to assume natural explanations that they wouldn't recognize an artificial object if it flew past Mars. There's historical precedent for this. When pulsars were first discovered in 1967, they were so regular that astronomers briefly considered whether they might be alien beacons. They even nicknamed the first one LGM-1. Of course, they turned out to be neutron stars, natural phenomena, but they considered the possibility. They looked at the evidence. They ruled it out based on data, not assumption. That's what Loeb says we should do with 3I Atlas. Here's what makes this time sensitive. On December 19th, 12 days from now, 3I Atlas will make its closest approach to Earth still. Distant at 170 million miles, but close enough for our best telescopes to gather detailed data. Then in March, it will pass near Jupiter. After that, it's gone forever, accelerating back into interstellar space at over 150 kilometers per second. That's 150,000 miles per hour. Every major space telescope is pointed at it right now. Hubble Webb, ground-based observatories around the world. We're gathering more data on this object than any interstellar visitor in history. Within the next few months, we should have definitive spectroscopic data, detailed measurements of any outgassing and precise tracking of its trajectory. Either the evidence will confirm it's a comet and put the debate to rest, or we'll find something that doesn't fit, some measurement that can't be explained by natural processes. We grew up in an era when we looked at the stars and believed we'd have answers. By now, we put men on the moon. We sent Voyager into interstellar space. We built telescopes that can see to the edge of the universe. But here we are in 2025, and we still can't agree on what's flying past our planet. Maybe that's fitting. Maybe the biggest questions never have simple answers. What do you think? Is Loeb asking the right questions, or is he seeing patterns where none exist? Is NASA being appropriately skeptical or overly cautious? I don't know. If we know 12 days from now, 3I Atlas will be as close as it's ever going to get. Whatever it is, we're about to get our best look, and maybe, just maybe, we'll finally know if we're alone. I'll be watching the data. I hope you'll be watching with me.